Hello, welcome to my channel. In this video, we are going to be solving problem under equilibrium. And the problem we are going to be solving is given in the form of a diagram. So we have this diagram and the question that arises is given as, if the beam is uniform, determine the force that each person exerts on the beam. So to solve this problem, let's quickly check out some of the hidden parameters. So first of all is the length of the beam. So the length is given as 7.6, the length of the beam. Then we also have the distance from this edge to this first person. It's given as 1 meter. Then the distance from this second person to this edge is given as 2 meters. Okay, so the weight of the beam, because it is uniform, acts at the center and it's given as 350 Newton. So then also we notice that this person exerts a force upward. This one also exerts a force, so we can call them reactions. So we call this first person reaction 1 and the second person reaction 2. Now to solve this problem, we apply the condition for equilibrium, which states that the sum of the upward force must be equal to the sum of the downward force. So the downward force is only the weight. So and it will be equal to the sum of the upward reactions which are pointing upward. So we have the weight of the beam is equal to R1 plus R2. Then, since we know our W, we have 350 equal to R1 plus R2. Now, we have only one equation with two unknown. So as usual, it will be difficult for us to solve for R1 and R2 with just one equation. We have to devise the second equation, which is the equation for torque. And it's given as the clockwise torque must be equal to anti-clockwise torque. Now, for us to solve using this torque, generate the equation for this expression, we have to assume that there is a turning point at this point or at this point. So, but let's take this one, the turning point at this point. So if there's a turning point here, the clockwise torque is given by this particular force, the weight of the beam, times the perpendicular distance from here to this turning point. And likewise, this one, because the person at this point can also drag upward, the beam upward, pull it upward, then the anti-clockwise torque will now be the reaction times the distance from here, perpendicular distance to this point. And that is given as 350, which is the clockwise, 350 times the distance from here to here. We already know from here to here is 3.8. So 3.8 minus 1 will give us 2.8. So the distance from here to this point. And it will be equal to the anti-clockwise torque, which is R2 times the distance from here to this point. We already know from here to here is 2. That means from here to here will be 5.6. So 5.6 minus 1 will give us 4.6. So at the end of the day, we can make R2 the survey formula. We get R2 equal to this expression. And on simplification, we have R2 equal to 213 Newton approximately. Now that we know this, we can slot this one into this expression and get our R1. R1 equal to the weight of the beam minus R2, which is already known. Then R1 equal to 350 minus 213. R1 equal to 137 Newton. So if we bring these two reactions out, we have our R1 equal to 137 Newton and our R2 equal to 213 Newton. So we can see that the reaction or the force exerted by this second person is more than the force exerted. So this can give us an insight into which of them will experience the larger force. So those who are close, whoever is closer to the weight will experience a larger force compared to whoever is closer to the edge. I hope this helps. Please like, share, and follow for more, and also subscribe. Thank you.